Okay, now we're going to talk about learning target 24. We're going to explain the way the position of the Earth, Sun, and Moon create tides and eclipses, and which in turn creates different climates on Earth. So, our essential question for today is, how would the tides be different if the Earth had no moons or two moons? So, a solar eclipse occurs during the new moon phase. The moon blocks sunlight from Earth. So this is a picture, sun, moon, Earth. So we're in a new moon phase, and we're going to show you, I'm going to have you watch a short video on how this works. Okay, here we go. The ecliptic is the line between the Earth and the sun. What you're seeing right now is a side view of the moon's orbit around Earth. Okay, the moon's orbit acts like a top with the moon on the rim. So keeping the 5-degree angle with the ecliptic, let's look at the moon's orbit. Okay, every once in a while, it'll make a complete circuit about every 17 years where the moon and the Earth and sun are in complete alignment. And that means the moon passes on the ecliptic between the sun and the Earth at the same time that the sun and the Earth are on the ecliptic. This rarely happens, but when the sun, moon, and Earth align, the sun is blocked from view. The new moon casts a small shadow on the Earth, hiding the sun, a solar eclipse. That's what the shadow that's cast on the Earth by the moon looks like. And the people in the shadow experience the total eclipse. Okay. So if you take a look at this diagram right here, the people who receive a total eclipse, that was that dark shadow you saw on the Earth, that means they're in what's called the umbra. Then there is a lighter part of the shadow cast by the moon that's called the penumbra, and you see a partial eclipse, not a total eclipse. Okay, a lunar eclipse is a little bit different. This occurs in the full moon phase. The full moon looks red to the Earth, blocking some sunlight, and the Earth actually transmits some of the sunlight to the moon. So we're going to watch what happens here. Okay. So the Earth casts a long shadow behind it, usually the moon's height above or below the ecliptic. Has the moon missed the shadow completely, and we see a normal full moon. So you can see up there, we'll see a normal full moon. However, every once in a while, the moon will line up on the ecliptic, and we'll see a lunar eclipse. So notice that the moon does not wink out. The reason is that the Earth's atmosphere refracts some of the sunlight onto the moon, and so the moon appears kind of orangish brown. And because the Earth casts a bigger shadow than the moon's shadow on the sun, the lunar eclipse can happen about once a year. Whereas a solar eclipse, it only happens about once every 17 years. And that's what the moon looks like during a lunar eclipse. Okay, and there's another picture for the lunar eclipse. Okay, Now we're going to talk about how the position of the Earth, Sun, and Moon can create tides. Tides occur because of the pull of gravity of the Moon and the Sun on the Earth's oceans. This can cause stormy weather. So the Moon does have an effect on our weather. Because the Moon is closer to the Earth, it has the greatest effects on our tides. Remember, gravity depends on distance. The Moon is closer than the Sun, so the Moon has the greatest effect. You have 2 high tides and 2 low tides every 24 hours. Okay, a tidal force is the difference in strength of gravity between 2 points. Remember, mass and distance determine strength. So that is why the Moon has a greater tidal force on the Earth than the Sun. So now we're going to look at the 2 different types of tides. We have what's called a spring and a neap tide. Spring tides occur during the new and full moon phase of the moon. This is when we're going to have the highest tides and the lowest tides. And the reason for that is because the sun and the moon are in alignment. So when they're in alignment, they're both pulling in the same direction on the Earth's oceans. In neap tides, these occur during the first and third quarter. We have lower high tides and higher low tides compared to spring tides. This is because the sun and moon are not in alignment. The moon has a stronger gravitational pull than the sun, but the sun is still pulling on the Earth's oceans as well. They're just pulling in opposite directions. So you'll have high tides right here, but they won't be as high as spring tides because you have the moon plus the sun. But we'll have low tides that will be not as low because you still have the sun pulling, whereas over here you have nothing pulling to create these low tides. So I'm going to show you a video that explains that. Okay, here we go with spring tides. The Earth, Moon, and Sun are in alignment, and you can see as the Moon starts to move, the tides get smaller when you don't have both the Sun and the Moon pulling on the Earth's oceans. These are the neap tides when the Moon, Earth, and Sun are at a right angle. This is a spring tide. Notice the high tides are getting a lot higher. The low tides are really low. Okay, neap tide. And I want to show you guys right here. The high tides are not as high as the spring tides, but look at the lows. The lows are not as low as the spring tides either. So neap tides have lower high tides, but have higher low tides. We'll see that when I show you the spring tide again. Okay, so the spring tides have higher high tides and lower low tides compared to the neap tides. And it's probably be a good idea to draw all these diagrams for the spring and neap tides and also for your solar and lunar eclipses. Okay, so hopefully you can be able to explain how the Earth, Sun, and Moon create tides and eclipses. And because of that, because of the tides, they're going to create stormier weather on Earth.